Next concept, that would be power. So how powerful are you? So what is power? Power is a quantity that tells you how fast work is done. Okay, power is the amount of work done divided by the time it takes to do that work. Mathematically, it's expressed by this. Okay, so work divided by time. So it is your rate um, of doing work. So it will tell you how fast are you when it comes to doing work. So we have also this formula. How do we get from this? Okay, remember if this is power. Okay, when you break down work, it becomes force multiplied by distance over t. So in this case, okay, we have now the force here. And distance divided by time. Okay, we have this. Okay, when you combine this two, it becomes this. So I hope that's clear. And then it's the rate to which work is done. Power is measured in joules per second or watts. It is after James Watt. Okay, so you have this formula here. So is doing greater work different from doing work faster? Let's find out. So I have here my two friends. We have Jake and Ju. Okay, Jake, okay, carries a 50-kilogram barbell. Okay, 50-kilogram barbell. It's like one sack of rice. Okay, and from a distance of 1.5 meters from the ground up to here, up to here. Okay, that's 1.5 meters. Okay, and how fast? Uh, he did that in just 1.2 seconds. Okay, next we have Ju. The same thing, this barbell here weigh 50 kilogram. Okay, and he carried that barbell from the floor to up to here. It's 1.5 meters. But it took him 3 seconds to do that. So I want you to compare the work done by Ju and Jake. And next question, this is the first question. Second question is, who has done his work faster? In short, who is more powerful? Hmm. So we have here Jake and Joe. Both of them has carried a barbell that weighs 50 kilogram in a distance from the floor that's 1.5 meters. With a time for Jake that's 1.2 seconds, and for Joe that's for 3 seconds. Okay, and since they pick up the barbell from the ground up, going up. Okay, so we have to factor the gravitational acceleration because later on you're gonna use this one. Okay, next is the first being asked is um, who has done more work? So that's the question, who has done more work? So we have to find work first. And since it's vertical, so we have to use the formula for vertical. So we have this. So you have to review your notes and you will find it. So do we have mass? Yes. Do we have gravitational acceleration here? And do we have the height or the distance? Yes. Okay, well and good. The same thing here. It's the same thing here. Okay. Now, so pure substitution, 50 kilogram for the mass, 9.8 meter per second squared for the gravitational acceleration, and for the height or distance, it's 1.5 meters. The same thing with Joe. Okay. So the question is, who has done more work? Yes, they both uh, have an equal work done. Okay, so they do the same amount of work, which is 735 joules. Okay, but the next question is who is more powerful or who has done the work faster? So we're looking for power. Okay, and power in a previous discussion is defined by or is mathematically expressed by work divided by time. Okay, so do we have work here? Yes. Okay, then the time, use this time here for Jake and time for Joe. Okay, and then you get this number. So who has a greater magnitude of power? We have Jake. So we could conclude that Jake is much powerful to do. It means he can do the same amount of work but much faster. A force of 40 Newton is needed to keep a 10-kilogram body moving at a constant velocity of 4 meters per second. What power is needed to sustain the motion of the mass? Now, here's the given. We have the force, which is 40 Newton. Next would be the mass, that's 10 kilogram, and velocity, which is 4 meter per second. So what's being asked? That's the power. Okay. And then the formula for power, we have this one because we all know power is the rate of doing work, meaning you're gonna tell how fast the work is being done. Okay. So if we're gonna break this down, work is equals to force multiplied by displacement or distance, then convert the work here and it becomes like this. And do you still remember this formula? It's coming from here. The velocity is equal to displacement divided by time, and then when you cross multiply, that's d is equals to vt. Okay, the same thing with here. So change the z into this one. So it becomes like this. And then, okay, cancel these things. Okay, sorry. And it becomes FB, or force multiplied by velocity. So this will be the new formula for power. So you have to use this one in our solution. And then the force, we have the value of the force, and we also have the value of the velocity. So it runs like this. Okay, and when you combine Newton meter over second, and when you combine these units here, it becomes watts. So the answer here is 160 watts. Okay, that's all. Thank you and goodbye.